All right, good afternoon again, ladies and gentlemen. This is Resh Mahaber, and I wanted to talk to you guys a little bit about for the book we're using at Wayne State University, which is section 1.6 is word problems, okay? But more importantly, it's systems of equations, and that's what I want to talk about. So, word problems, okay? And it's not as bad as you think it is. Now, if I gave most of you guys an equation, if you guys are at the level where you're looking at this video, that means that you have no problem solving equations, okay? Or very little, seldom, right? Got some rust you got to knock off. So why are word problems so difficult? It's not that it's the math that's hard. Math is never hard. It's the reading part. And if it's in English, then you know that we have different contexts, different stresses, different tenses, subjects, verbs, predicates, pronouns, adverbs. Like there's so many things that is very gray in the English language. So when you translate it into a black and white language known as mathematics, it gets very, very sketchy. So you got to be very, very good and very, very cognizant of what words mean. So what my point is how do you get good at word problems? You do a lot of them. You do so many word problems that the things that are unknown to you, you have an opportunity to go look it up. It exposes what you don't know. So you can go Google it. You can go get an encyclopedia. You can go talk to a fellow classmate. But that way, when you encounter it again, you've expanded your horizons, your vocabulary, and that's really what it comes down to. It's vocabulary. So we're going to talk about a couple different word problems, and you'll notice every higher math class you go to, the word problems become more advanced. And it's not that they are more advanced; it's just that how they're wording is how they're worded is very, very sometimes weird almost because you can stress things in different ways and phrase them in different ways. So here's a word problem I want you guys to take a look at, and we will talk about it together. All right, so I'm going to try to bring this up so we can see the whole shebang. All right, so here we go. It says a poster has a rectangular printed area. A poster has a rectangular printed area that is 100 centimeters by 140 centimeters, and a blank strip of uniform width around the edge. The perimeter of the poster is 1.5 times the perimeter of the printed area. What is the width of the blank strip? Okay, so clearly this is a tougher problem just because they are putting a picture together that might not be the same picture you're accustomed to. Okay, so a poster. So it's where we got to be familiar. Let's start over again. We're going to read very, very slowly. Remember, everything they taught you back in the day about reading doesn't apply right now. What do I mean by that? Context clues. They said just skip a big word if you don't know, and if you keep reading, it'll define itself to you. Yeah, if you have a 200-page book, that works, but it doesn't work when you only have 2 sentences, okay? So if you don't know something, you got to stop and Google it, or stop and talk to somebody, or just stop and just become more familiar with it. So let's see if we could translate this, and we'll be good. Now, I'm going to tell you, this is the 4-step process of doing word problems in general. The first one is always going to be familiarize yourself. Okay, and that's what we did when we read we're going to read the problem now. The first time we just read it to be reading it. Now we are going to actually try to familiarize ourselves. So it's a poster. Do you know what a poster looks like? Yeah, there's different kinds, right? There are rectangular ones, there's triangular ones, there's circular ones, right? But they stress here that it is a rectangular, a poster has a rectangular printed area. Okay, so they're stressing the area, but then they give you 100 centimeters by 140 centimeters. So they gave you the dimensions of the printed area. So this is already very complex. I need to draw a picture, a poster that is rectangular. So here we go. Now this could be incorrect. I might need to erase and start all over again. Here's a rectangle. Okay, well, my attempt to draw a rectangle. Now I don't know about you guys. When I have posters, they're normally centered on the piece of paper, so they look kind of like this when they're framed up real good. Okay, so they say this: a poster has a rectangular printed area, right, of 100 centimeters by 140 centimeters. So this is that rectangular printed area. Okay, right in here, there's a picture in here. Let me draw something here so you guys know what I'm talking about here. Here's me. Okay, so that's the poster. Okay, and they say that's 100 centimeters by 140 centimeters. So I know from here to here is 100 centimeters, and from here to here, notice I didn't do the entire picture, is 140 centimeters. Okay, let's keep it moving. Then it says, and a uniform A blank strip of uniform width. Uniform width around the edges. A blank strip of uniform width. So what does that mean? Are they talking about the width here to here? No. They're talking about this. This is supposed to be the same width all the way around the poster. Now that they should have said something in a much better sense, because in common language you don't say a blank strip of uniform width around the edges. We say a border. Now if they said it had a blank border around it, that made perfect sense. So, but that's really what's going on, a blank border. And obviously the border, you would never buy something that wasn't the same all the way around. If it was off center, it would look terrible. Okay, so that's the whole purpose of it. Notice I'm spending a lot of time giving familiarity to this, because if you don't, it's no good. Okay. Okay, then it says the perimeter of the poster. The poster itself, not the printed area. So they're saying the perimeter of the poster. So that's what I'm going to do. Underneath it, I'm going to say perimeter of poster. Okay. Is. Alright, guys, what does the word is mean? I'm going step by step here. Is, you should say equals 1.5 times. Now, I don't know about you guys, but 1.5 just means the number 1.5. Okay, 1.5 times the perimeter of the printed area. So what is the printed area? The printed area is me, this guy right here. Alright, now here's the question, which is the second step of any real good word problem once we've kind of figured out what's what. Okay, now you figure out the question is, because you never know, the question could be something that really doesn't need all this stuff. I had a guy in undergrad for a philosophy course, and he one of the exams was a stapled piece of paper. It was 7 font, single space, and I just started reading it. And everybody in class turned in their test within the first couple minutes, right? And I couldn't figure out why. I got to the end of class after I finally got to the question. I couldn't figure out why, right? I was the only guy there. And then I finally got to the question after reading this ridiculously fonted piece of paper. And this is about an hour in. And the question was, what color is Prince Charming's white horse? Obviously, that had nothing to do with anything that I read, and the answer was white. So I'm going to urge you that we must, step number 2 is figure out what's the question and define variables. Okay? If you don't define your variables, you don't know what you're solving for. And the variables will always come from your question. So the question is, what's the width of the blank strip? So the question is so let x, I'm going to define my variables, equal the width of blank strip. Now, what width are we talking about here? Remember, blank strip is the border, so we're talking about the distance from here to here, here to here, here to here. No, it's uniform all the way around, so you got to know what we're talking about here. Is everybody okay so far? So, alright, I think we got a pretty good idea of what's going on here. So now, this brings us to step 3, which is try to pull out as much mathematical equations out of this as we can. And I think we already got one really good one here. It says the perimeter of the poster is 1/2 the perimeter. So we're going to try to exploit this, and this is going to bring us to step 3. Let me see if I can make this a little smaller so you can see what I'm writing here. Step 3. Maybe I can squish this up too. Hey, look at that. To step 3, which is solving. Okay, so now, which is translating. Sorry, translate into math. Right, variables and whatnot. Okay, so as a poster has a rectangular perimeter, right? I think we have already got all the details out of here. So let's even get to nitty gritty. It says the perimeter of the poster. So now you got to recall to yourself, what's perimeter? Now, everyone wants to say, oh, 2L plus 2W because we're talking about a rectangle. Guys, don't church stuff up, okay? Perimeter is exactly what perimeter is. It's all the outside added together. So that's this long side, this long side, this long side, and this long side. Okay, it's really that simple. Now we're talking about the entire poster. So I'm actually going to do the perimeter of the printed area first, because I think that might be a little easier. I'm going to say 3/2, which is the same thing as 1.5 times the perimeter of the printed area. So what's the printed area? Well, it's this side, right? What side is that? Plus this side, plus this side, plus this side, right? Now each one of those, because that is a rectangle, all those sides, if this is 100, this is 100. If this is 140, this is 140. So this is 100 plus 100 plus 140 plus 140. Done. All right. Now we got to figure out, with this Junjet of this thing on his left side, that what's the perimeter of the actual poster itself? Well, we know from here to here is 100, right? So what the heck is in this little piece of area? What do we call that? Well, if you notice, this is that uniform width all the way around that border. And same thing here. This is uniform width all the way around. So to get the full side here, this is going to be the distance of x, right? Why? Because x is the width of the blank strip. So that's the full side. So this entire side is 2x plus 100. Isn't that nice? X plus 100. And then this entire side, by the same caveat, because it's uniform, that's x. That's x. And this is 140. So this entire side is 2x. Uh-oh. Looks like I'm running out of space again. I hate when this happens. Give me a second. Is 2x plus 140. Now note, perimeter sum of all sides. So I need to add this side, which is 2x plus 100, plus this side, which is 2x plus 140. But note, I have another 2x plus 140 on this left side, and then another 2x plus 100 on the top side. So now, add it all together. What do we end up with? Well, I think we end up with 8x plus 200. 280 is 480. I think I did that right. And same thing. Oh, I just did that, didn't I? This is 480. Now, I think we can solve. This is a pretty rinky-dink problem, if I remember correctly. All right, so let's see here. Let's try to do this down. And since I'm running out of space, I'm going to speed through some of the work. 3/2 of 480 minus a full 480 is a half of 480, which should be 240. And then x is going to be equal to 30. So that means that border is 30. But what's the units on this? Well, everything was in centimeters. So this thing should be in centimeters as well. Bingo. So it wasn't a hard problem. You just had to take your time decrypting it. And that's what it really comes down to. So this problem took 11 minutes. So we're going to do one more out of the two I had in mind to actually get a good idea. Let's do, this is actually a really good problem, this Kieran problem. I'm going to leave this for you guys to do at the end of the video and let you guys dig through it. But I want to talk about this one. This is a good one. Let me clean my plate real quick. All right, it says a city lot has a shape of a right triangle. So everything you know about right triangles should come in your mind right now. So Pythagorean theorem. Here's my city lot. I don't know why you would have a city lot that is a triangle, but Pythagorean theorem. I think Pythagorean theorem is really the big one that jumps out, but it's also a normal triangle, so you can actually have area stuff, which is 1/2 base times height, where perimeters add all the sides together. Okay, so now they give you some details here, and you should get to a point where you can start translating and defining your variables as you go. So let's see if we can figure this out and do it all in a good enough time span, and maybe we'll have enough time to fit in that other problem. A city lot has a shape of a right triangle. We drew that. Whose hypotenuse? All right, guys. What's the hypotenuse? This is it. All right. So the hypotenuse is 7 longer. So it's plus 7 of what? I don't know yet. I haven't read it. 7 longer than one of. That's not f. It's of the other side. So pick a side. I'm gonna call this something. Give me a dummy variable. I'll call it x. So this guy would be x plus 7. Okay. I don't know if I defined that correctly. I haven't actually put it in stone yet. It might be something rinky-dink. Okay. Then it says the perimeter of the lot is 392 feet. Now it says, this is the big question, how long is each side of the lot? So that means I need to figure out what this side is, and I don't know if this side right here is the same as this side right here. So I'm going to call this y. Okay, and then here's the point. If I can find what x and y is, I pretty much am good. Okay, so this one you can define or not define these. I always say that defining them makes it make a little bit more sense. All right, so we got to put some things together. Well, how long is each side? So that means find x and find y. Okay, so they say perimeter, so let's see if I can figure out perimeter. Perimeter is y plus x plus x plus 7. Notice nothing prompted me to put this y in here. Sometimes giving it a name helps a lot. Okay, so that's all I did is give it a name, so I knew what to call it when I put it into this equation. So y is, oops, I said is and put equal sign. Look at that. 2x plus 7 equals 392. So y plus 2x. I'm in the habit of making things nice and pretty. What's 392 minus 7, guys? I don't know. Let's go to the side. Minus 7. And this is what I urge you to do. Like right now, I'm running on fumes because I'm a little bit exhausted. So what you got to learn how to do is when you start running on fumes is show more work. Okay? So here we are, 385. But do we know anything else? This has two variables in it. I can't solve for anything with two variables with just one equation. I need two equations to solve for two variables. So what else do we know? Well, Pythagorean theorem is the most obvious. Y squared plus x squared equals x plus 7 squared. And then I think I could just substitute in and grind it out, right? I think that makes sense. But let's multiply the right side out and see if it gives me some goodness. This is x squared plus 14x plus 49. And then, oh look, the math gods have smiled on our poor souls. Y squared equals 14x plus 49. And I think I could solve for y and just drop it right in there, couldn't I? So y, and this is called substitution, ladies and gentlemen. 385. Oh my god, that number is huge. 385 x. And once again, why did I use 392? Because the perimeter is the sum of all the sides. So here we are. That's it. Ugh. This is going to be nasty. Why? Because the number is just huge. That is why. Now, you guys are probably saying, well, Resh, why can't I just use a calculator for this? Because you gain something from dealing with the computation. So I'm going to grind through the computation with you, or maybe I shouldn't in time in the video. But if you could solve this polynomial, you have the answer for this. Okay? So when we multiply this out, what do we end up with? Well, I don't know. Let's see here. 385. Remember, show the work, guys. When the stuff gets harder, you always show the work. And I'm going to show you some cool little nifty math tricks that I use to actually make my life better. Now, I have not done this problem yet, so it's going to be easy. So this times that, I don't know what that is, and I'm not going to waste my time writing it out, but I know it's 385 squared. Okay, this guy times that guy, let's double 385. What do we get? 385 times 2, 0.16717. 77, that's pretty good. That's pretty nice. So that's minus 770x minus 770x plus 4x squared equals 14x plus 49. All right, looking good, looking good. Okay, I've realized that this is going to be much longer for this video than necessary. So this is what I'm going to encourage you to do. Solve this polynomial, just so I'm not sitting here writing the same problem out over and over again. And if you can solve the polynomial, and which I think you guys should be able to, you should be able to rock and roll. But the big concept was developing your two systems of equations, and then substituting one into the other one and grinding it through. The numbers are bigger, but you guys will be able to work it out with a little bit of time and effort. Let's talk about that last problem real quick. Okay, erase. The last problem was a really good one, okay, and this one should be a blast from the past. It says Karen drove from Tortuga to Cactus. So guys, when in doubt, draw a picture. I'm gonna call this Tortuga. I'm gonna call this Cactus. Okay, a distance of, oh, they give you a distance. So here, from here to here, the distance is 250 miles. Okay, she increased her speed by 10 miles per hour for a 360-mile trip from Cactus to Dry Junction. So let's pull Dry Junction here, and she drove from here to here at 360 miles, right? But then they said something. They said she increased her speed by 10 miles per hour. Speed is not a distance, it is a rate. So this is plus 10. Plus 10 of what? Plus 10 miles per hour of whatever this guy is. So we need to call this something. Okay, I'm going to say let the rate of this guy just be r. Okay, just be r. So this guy ends up being r plus 10. Makes good sense. I know it's bad etiquette to have like an actual r here. R can't equal r plus 10, but oops, you still can't see anything, can you? Let me see if I can move this out the way. Make life warm and fuzzy inside. Okay. Now it says if the total trip took 11 hours, right? If the total trip took 11 hours, that means whatever the time was here and the time was here, the total trip, that means when you add both times, that should be 11. Now, I don't know. There won't be a straight split down the middle. It should be imbalanced because of the different distances and different speeds, okay? What is the speed from Tortuga to Cactus? So they're asking what is what is r, or what we call r here. So you need to ask yourself, what is time? Well, distance equals rate times time. So you know time is distance over rate. So check this out. T1 from this guy would equal 250 over r. T2 over on this guy from Cactus to Dry Junction will be 360 over r plus 10. So now plug it in, guys. 250 over r plus 360 over r plus 10. And I think we can solve this guy without much difficulty. Okay, we're already 20 minutes in, so I'm not going to bug you guys with the solving part, but I'm telling you this: solve. It's good practice. It's good practice to let you know you guys can clear fractions and solve for r without running into any issues, and it really tests your ability to factor. Okay, this is actually right off your final exam from last semester, so you guys should be okay. Next video to come up, we will talk about inequalities, linear and nonlinear, and I stress out about linear and nonlinear because they're extremely important. Might even be a two-part video depending on how much I want to stress out about it. So when in doubt, remember, if you want to go somewhere you've never been before, you got to do something you've never done. That means you got to go to distance, you've got to grind, you have to get uncomfortable. And remember, if you're not uncomfortable, you're not growing. So you got to be uncomfortable. All right, guys, signing off. Got any questions? Save it for me. Shoot me an email. I'll see you guys later. Bye-bye.